Now let's look at more complicated example. We are going to write a function how to merge two sorted lists. For example, we had a first list and we have the second sorted list as well, and we want to merge them together. This approach will contain 4 parts. The first one, which I'm not going to write, because we've done this several times. At first we have to check if neither of the lists contains nodes, if it's empty. Just if first equals to null pointer and second equals to null pointer, it means return null pointer. At first part, we will start with the initial state. We will need our 2 more pointers. We need the temporary pointer, and we will need the last pointer, which the pointer which we will call last. Node temp equals null pointer, and node last equals null pointer. We want to merge these 2 lists and print after that in the sorted order. It means we have to figure out first which of the list contains the smallest value in the first node. It means we have to compare these 2 data. So if first data is less than second data, we just need 3 steps. The first step, we need to move these 2 pointers to the smallest head. In this case, if first data is less than second data, 2 is less than 3, we will need to move these 2 pointers here. It means temp equals last equals first. This is the first step. The second step, we will need to move our head to the next node. Here is head is first, we will move it to the second node. First equals first, next. And the last step, we need to last next point to the null pointer. Last next equals null pointer. The same thing, the same steps we have to do for the second condition if it would be opposite. For example, if the value in this node will be smaller, for example 1. I will not write these steps because they're exactly the same. We would have to move these 2 pointers to this node, move second, and reassign last next to the null pointer. Let's move to the next part. We have to move we moved our first. Our first is now here. So now we will traverse our 2 lists while first is not equal null pointer, and this is part 2, and second is not equals null pointer. If we will continue to compare, if first data, the same thing, we are looking for the smallest data, less than second data. Now we are comparing this data 4 with 3, and we will need 4 steps here. If this is true, which is not in this example because 4 is not less than 3, so this will be false. For this example, because I have the smallest value in the second list, I will write this second statement. So if we will have to do the same thing for the first data, but I will flip it, because in our example our value data is in the second list. If second data, let's point last next to this smallest node. Last next equals second in this case. Last node points here. We'll have to link it with this node. Let's move our head to the next node. Second equals second next. Make this node points to the null pointer. I skipped one step because we had to move not only last next, we have to move last as well. So after this line, after last points to next, we'll add last equals second. Because before we moved our second head, we have to move our last point here. Yeah. So now we relinked, we have our two nodes already in our new list. It's the same list, we just relink our pointers. 2 points to 3. And we continue doing that after one of our list will hit the end of the list. So let's compare, let's continue. I will not write the code, but I will just say what we will do next. After we've done that, we will continue to compare our data. If first data is less than second data. In this case, yes, first is less, 4 is less than 5. We will point last next, which is here. We will point to this node. We will move our head to the next node. We will move this head to the next node. We will move our last pointer. We will move our last to first. Last equals first. Point to the same thing. And we will make last next to null pointer. Points to nothing. After that, we will continue to compare first data 6 with the second data 5. 5 is less than 6. It means we will. What is last next? This is last next. We'll make last next point to this node. We will move our head, and we will move our last to the same node. And make last next point to null pointer. Continue. 6 is less than 7. The same thing. From here, last next point to this node. Move our first. Move our first, and now we hit null pointer, because after that it was null pointer. First points to the null pointer. Last. Let's move last. Point to the null pointer. And we'll make this null pointer as well. And now we are going to do the last part, which is because we're already out of the loop. We hit null pointer for the first. And now we just have to link our node that was left, which contains data 7 from the second list. So part 4 is link. So if first is not equals null pointer, it means in our first list the node is remaining. It means we will have to link our node from the first. which is not our case. So what we have to do else, it means our second, it means first hits a null point, and we have to link our remaining node from the second list. It means we will have to point last next to the second. Now second is here, points to the 7, and we'll have to link our last node. If the second list hits the null pointer first, it means we have to link remaining nodes from the first list. Last next equals first.